Ever struggled to see those tiny superficial spider veins on the face or legs because of blinding glare on the skin? Well, if you're a professional who performs procedures like Microsclerotherapy or Shortwave Diathermy, you know how frustrating it is when that surface reflection obscures the very thing you need to target. Well, today I'm going to show you how to solve that problem for under £50 by building your own DIY cross-polarized head-mounted magnifier system. While commercial systems like the Syris V900L are amazing, they can be a significant investment. This guide will walk you through how to replicate that essential glare-reducing function with just a few affordable parts: a powerful headlamp, a headband magnifier, and self-adhesive polarizing film. This is a game changer for anyone who needs a practical and effective solution for glare-free magnified viewing of both facial spider veins and telangiectasias in the legs. Now, while this entire project is pretty straightforward, there's one crucial step that makes this whole system work. It's all in the final alignment, and I'll show you exactly how to get it right at the end of the video. So be sure to stay to the end. So how does this work? It's all about cross-polarization. Light from a standard headlight is unpolarized. The light waves oscillate in every direction. When this light hits the skin, some of it reflects directly off the surface, creating that blinding glare. This glare largely retains its original unpolarized state. However, the light that penetrates the skin and scatters off the vessels we need to see, becomes depolarized, meaning its polarization is randomized. In this project, I'm going to use two linear polarizing filters. First, I'll place one filter over my headlight. This filter acts like a gate, only letting light waves that are aligned with its axis pass through. So the light hitting the skin is linearly polarized, and most significantly, the glare reflected from the surface of the skin remains polarized in the same orientation. Next, I'll place the second filter on my magnifier. The key is to orient this second filter exactly perpendicular to the first one. Let me show you what I mean. If we have two polarizing films at 90 degrees, they block all the light when they're crossed. Because the second filter is perpendicular to the polarized glare reflecting off the skin, it pretty much blocks it completely. But the scattered, depolarized light from the vessels underneath the surface still have many components that can pass through the second filter, allowing us to see them with stunning clarity. The end result? The glare is gone, and the vessels are revealed. Let's build this thing. Here's a quick overview of the steps we'll follow. Step 1. Gather your components. You'll need a bright LED headlight, a comfortable head-mounted magnifier, and a linear polarizing self-adhesive sheet. I've linked the specific products I'm using in the description below. Step 2. Prepare the filters. Simply cut two pieces from the polarizing film, one to fit on the rotating light source of your headlight and one to fit your magnifier. Step 3. Attach the filters. The polarizing film is self-adhesive, so just attach the first filter straight onto the light source of your headlight. Make sure it covers the light source completely. Next, attach the second filter to your magnifying lens. The orientation doesn't matter at this stage, as the final alignment will be done by rotating the headlight. Step 4. Final assembly and alignment. Put the headgear on and look at a reflective surface like the back of your hand through the magnifier. The final step is to slowly and carefully rotate the headlight's rotating rim while watching the glare. You'll see the glare vanish when the headlight's filter is precisely 90 degrees to the magnifier's filter. So there you have it, a fully functional DIY cross-polarized head-mounted magnifier. This simple, cost-effective setup will dramatically reduce glare, allowing you to see the fine details of superficial vessels and improve the precision of your procedures, whether it's for microsclerotherapy on the legs or shortwave diathermy on the face. For a full, detailed guide with all the specifications, a complete materials list, and troubleshooting tips, you can download my free PDF guide linked in the description below. Now, while this DIY system is incredibly useful, it's not a direct replacement for a professional, purpose-built system like the Syris headlamp. If you find this low-cost setup helpful in your practice, you might just find that the professional-grade performance of a Syris system is a worthwhile investment for you long-term. Now, I hope you found this useful. If you did, please consider liking and sharing. It really does help get the word out. Don't forget to subscribe for more tips and tutorials. Thank you for watching.